Good day, fellow fans of cybersecurity. My name is Abiodun Bas. Today, I'm welcoming you to my lab for which is my second act part one. And now I will be moving to the introduction. Firstly, I will say in this lab, I used Nikto, ZAP, and Nessus to scan K-2 and Metasploitable 2 using Kali Linux. The goal was to identify vulnerabilities, compare scanning tools, and analyze threats like the CSRF and SXS. I also apply the flow hypothesis method to trace root causes and consider ethical guidelines for vulnerability disclosure. Now let's get started. In this slide, I'm introducing the assignment objectives, which was to ethically exploit the K-True virtual machine. Using Kali Linux, I started by verifying my network setup using ifconfig to find my local IP. Then using Nmap, I scanned the network to discover the IP address of the KF2 target. This reconnaissance phase is critical in penetration testing because it helps us to understand what hosts and services are available before attempting any exploitation. After identifying the target machine's IP address, I used Nikto, a web server scanner that helps detect vulnerabilities such as outdated software, configuration issues, and common security problems. The scan showed that port 80 is open, indicating a web service running on target. It also identified a potential XX vulnerability, which was investigated further. This is a crucial step to identify surface level weaknesses before deeper exploitation. I would say this slide outlines the key objectives of the assignment. The process began with enumerating the target system and then running two widely used web vulnerability scanners, which are Nikto and OSWAP. Part of the goal was to compare these tools in terms of what they detect and how they operate. We I also focused on identifying specific threats like CSRF and XSS to deepen the assessment. I used Nessus to scan for border system vulnerabilities and documented 10 possible security issues in total. On this slide, I break down the core of the presentation. I apply the flow hypothesis methodologies to the K-2 virtual machine, which help me systematically analyze and map vulnerabilities. Each identified issue was traced to the root cause, allowing me to understand the underlying security gaps. I documented all the tools and techniques used, outlined potential attack vectors, and concluded with recommendations on how to responsibly disclose these vulnerabilities while summarizing their root causes. In this stage, I implemented the flow hypothesis methodology, which involved forming assumptions about possible vulnerabilities within the K-2 system based on observed behaviors or misconfigurations. These hypotheses were then tested to determine if they could lead to an exploitable flaw, helping narrow down the attack surface efficiently. During the vulnerability analysis, I observed the Apache 2.28 web server version, which is outdated and susceptible to known exploits exploits. I confirmed an SSS vulnerability that could allow attacker to inject malicious scripts into the site. Additionally, I would say port 80 exposed indicate the system might be vulnerable to DDoS attack, potentially disrupting service availability. To better understand the vulnerability in Apache 2.2.8, I conducted research and confirmed it is prone to cross-site scripting attacks. Using scanning tools such as Nikto and WhatsApp ZAP, I was able to identify and verify these issues effectively, helping mapping out possible exploitation path. I would say in tracing the vulnerabilities back to their origin, I found out that the outdated Apache 2.28 was a major factor. Its known issues, including the SSS and DDoS exposure, result from poor input validation and missing security updates. This gap highlights the needs of regular patching and secure coding practices. Finally, I would say here are the references I used to support the tools, concepts, and methodologies throughout this lab. They include documentation from Apache and Tenable unknown vulnerabilities, courses materials from Grand Canyon University, NIST's guideline on malware handling, and OSWAP's explanation of CRF's attack. These sources help me guide my analysis and reinforce industry best practice. I will say thank you again for listening. Thank you all for watching. I still remain the same, Abbas Abiodun. I wish every one of us best of luck in our journey at GCU. Thank you.